we're blowing a little bit of smoke right here, and we're using ice to push the air this way so that you can see kind of the effect that the air has, right?
I appreciate you, Carl.
Thank you so much.
So please introduce yourself. Hi.
Hi. Oh, my name is Carl Schlacke. I'm the CEO of Ventiva.
And are you showing off solid state cooling technology?
We're showing off solid state cooling. This is a device with no moving parts that blows air. And the air can be used to cool any one of a number of different electronic devices. The device that we're showing off today is actually laptops. So the first laptop that we have with it introduced in it is Dell. So we collaborated with both Dell and Intel to develop this. It uses 3 ICE devices.
Is it there?
It's same basic layout. This uses 1 ICE device. There's where the CPU would be. So heat pipe, ice, the same ice that's in here. And that ice is actually blowing air out this way. And that's how we would cool the CPU, as opposed to a traditional blower.
How does it work?
We energize the air electrically by energizing a small point, actually a wire. That wire then forms ions around it. And those ions move across a gap, and that gap in that movement, they collide with air molecules, and they create a flow of air.
How does it compare with like what Furore is talking about?
So Furore is a device, I can't really comment too much on their product other than to say that it uses MEMS to move membranes. This has no moving parts and actually uses electricity directly to move the air.
And how efficient is it?
Efficient in terms of what?
For example, you can put in a thin and light laptop,
Yes.
and it's not going to use all the battery.
It's not going to use all the battery life. That's
How's
correct.
it going to compare with a traditional cooling
It's
in
going
terms
to
of power consumption?
use a little bit more power than a traditional fan, traditional blower, but it gives you the benefits of very thin and very silent. So by putting our device in a laptop, for example, you can remove multiple millimeters without doing anything else.
And is there any chance you can run the laptop in a faster performance?
Yes.
So how high can you get?
We're showing today that we can run up to 40 watts.
And what would it usually do with a traditional cooling?
Traditional cooling, if you look at the back of this laptop here, the one that's kind of open in the back, you'll see that there's 2 brackets where they show where the fan would have been, right?
Yeah. Yeah.
Those fans are removed and they're replaced with a device that looks like this.
And you have all these different sizes?
We have all these different sizes for different applications, yes we do.
You can even put them in the phones in the future?
In the future, our intent is to move them down into handsets, yes.
Does that mean the phone can run as a full laptop speed?
It might be able to. It depends on the architecture and the thermal subsystem in the phone. But yes, that's our intent.
Are you working towards SSD? To help cool down the SSD?
Yes, that as well.
And what other markets you could potentially target?
Generally, anything in consumer electronics sub 40 watts is the kind of application that we can support. We're going to be looking for applications that require super thin and very quiet as kind of their modes of operation.
So
laptops
is there any way to turn down the performance to have a longer battery life and then boost it up as you need?
Just like a traditional fan, you can dial it up or dial it down, just depending on the performance that you need for your system.
So if you want, you can match the power consumption of traditional cooling, then you have lower performance, and then you boost it when you want.
Potentially we could, yes. It really does depend on what you're trying to achieve in your system.
And is it very expensive?
We're not disclosing a price at this time, but the intent is for it to be only marginally more expensive than a traditional blower.
So this is kind of like prototypes, or how soon is it mass production?
Mass production is probably in 2026.
All right, so next year, what needs to happen before you can do mass production?
We need to finish off a couple of the designs that we're engaged in. Dell is a great example of one of those. And
is it inside this one right now?
It's in both of those. Yes.
So
they're both the same machine.
Can you show? It's showing exactly.
Yeah, it's the same. So if you look, the back of this one is translucent. You can actually see through it.
Can you tilt this one so we can have a look?
Is this one translucent as well? Can you tilt that one up?
Can we see what's under?
Yeah. It's identical.
Right there. It's the same. So can I feel some air somewhere?
The back hinge, it's blowing sub 1 meter per second. So if you pick it up, you can feel it. If you go right here at the hinge location,
sorry.
Put your hand right in that location. It's very light.
Yeah.
Draft.
I want one of these to make your perfect.
Yeah, I feel very little air going on.
Yep.
So if you do some crazy video editing in 4K 60 and you render, it starts kicking up the air?
So this one is at full speed right now. So you will run full 15 watts Bloom Lake. No problem with that design. And so that, thank you.
Yeah.
No, I mean, can you hear me? Is that good?
Yeah.
So prototype concept uses Lunar Lake. Basically, we're running full 15 watt TDP at 23C ambient, full performance. And so there's no limitation within this system versus our standard system. You can see the base of the unit, right? So we've got a vapor chamber with dual fin stack solution. These two ice devices are cooling the fin stack directly. The third ice device is for skin cooling. So basically we're pulling air over this section of the system on the bottom and out the back. The vent structure is optimized for the ice device and the flow through it. And so we are managing pressure drop to get the flow needed out of the system.
So those little holes here, this is where the air goes out?
That's the air intake. And so what ends up happening, air flows this direction, goes in through this vent, goes through the wire, that first wire strips an electron from the air molecules, then it pulls it to the collector plate, which is a ground. And so it's just basically charged particle gets pulled basically to the ground, and that imparts momentum. And so it hits the surrounding air molecules, and you push air out.
Yeah. And then it comes out through
This hinge.
the hinge.
Yep. So if you look at it, the fin stack's there. It's being blown
Just in
out,
the hinge.
top and bottom of the hinge.
Wow.
Yeah.
So you don't need so much space to get the air out.
You can see it right here. And so basically right between that crack, that's where the hinge is located. The fin stack's right in this location and this location.
Nice. Okay, that's awesome.
Yep.
Okay, so a lot of people looking forward to this?
I think so. I mean, the proof of concept has shown like real capabilities as far as future technology, and the overall acoustics is a key advantage. So the acoustics on this system is around 0.1 zone at 15 watts. So it's way below the background noise. You can't hear it when you put it up to your ear. And that's the intention, right? So it's silent compute is the idea. And we've been on a journey at Dell for a long time. If you go back basically 2000, our acoustic spec for like the Latitude class, what they call Dell Pro now, was 2.5 zones, right? So we went from 2.5 zones. This product, what Dell Pro is 1 zone. This is 0.1 as a proof of concept. So this shows you what we can do with the capability and the technology. But this was hard. This isn't easy, right? So if you look at this is a partnership between Dell, Intel, and Ventiva to get to this point to prove feasibility in a product that you could do this. And this was really the first step in the journey.
Are you with the Dell?
I'm with Dell, yes.
And have you looked at at Furore?
I have. It's a great technology. It's a different technology, right? So really high static pressure, like orders of magnitude higher than a blower. But usually the flow is pretty low. This is kind of opposite of that. It's really high flow, low pressure. So if you look at the system, it's really important on designing it appropriately. The vents, the structure, the foot height is critical. The gaps are critical. The fin stack pitch is critical. Versus say the Furore stuff, it's going to be really tight spaces. So if you were at a very confined space that you need to push through, that's where that may make sense. This makes more sense for like PC total cooling because you're getting the volume of airflow out of the system.
Nice.
Yep.
It's really exciting to see what could be happening with solid state
Yep.
cooling. It's going to kind of revolutionize the performance people can achieve with a thin light device, right?
You've got it. And basically acoustics. So the biggest advantage right now is form factor and acoustics. And so if you look at the space, you got it? Yeah, if you look at the spacing, this was the existing blower. You can see the outline profile is the existing blower that we replaced with the ice device shown here, where the actual element is here, the outer housing is shown here. There's two different versions. There is a high voltage power supply in this location, which you do have to account for in that space, but it's still fundamentally about 20% volume savings. So bigger batteries, smaller systems, you can use that space for something else. It really enables us to have new ways of designing product.
I've seen today the announcement with the AMD.
Yep.
And how's it going with ARM?
Good.
Is Dell doing stuff with
Qualcomm? Yeah, and so we have historically. Dell's very silicon agnostic, right? We want to provide our customers the best technology for whatever they need. And that's what you're seeing with the announcement with AMD, right?
So this technology potentially could be great with all these CPUs,
It doesn't
right?
matter. It's heat agnostic. This is more of a cooling technology, not necessarily a silicon technology, and it can scale. Really, 15 watts, it's independent. You can have 15 watts in, say, an ARM product or an x86, it doesn't matter. It can scale from each individual product category.
I had once a Dell XPS 13 that started smoking up because I was using on a pillow, and it got too hot and I had to RMA it and stuff like that. This potentially, it looks like the angle of the air coming out, you could actually work more on pillows because it doesn't care so much about what happens under it, or?
Well, that's where you've got to be careful, right? The pressure head's lower, so for like a pillow, it really comes down to system design. So in that case, we're probably going to have edge venting where the venting comes in two directions. So if it's on a pillow, you have a secondary vent where it's coming from the top or bottom. So that's something we've been doing for a while. So if you look at like Alienware, we have a lot of top side vents and it's based upon volume of flow. And so that's probably more on the system design than the technology and making sure that we do that right on our side. But good point, good question.